Git hooks. In this presentation, we'll explore the concept of Git hooks and how they can be used to enhance your Git workflow. Git hooks are scripts that run automatically every time a particular event occurs in a Git repository. They provide a powerful way to automate tasks and enforce certain behaviors in your development process. Git hooks can be used for a variety of purposes, such as enforcing code style and quality standards, triggering build and deployment processes, sending notifications or alerts, and performing security checks. By leveraging Git hooks, you can streamline your development workflow, improve code quality, and ensure that your team follows best practices. In the following slides, we'll dive deeper into the different types of Git hooks, how to set them up, and some practical examples of how they can be used to improve your development process. Git provides a variety of hook scripts that you can use to automate different stages of your development workflow. Some of the most common Git hooks include 1. Pre-commit hook. This hook runs before a commit is created, allowing you to perform checks or validations on the changes being committed. For example, you can use a pre-commit hook to enforce code style guidelines or run linting checks. 2. Commit MSG hook. This hook runs after a commit message is created, giving you the opportunity to validate or modify the commit message. You can use this hook to ensure that commit messages follow a specific format or include relevant information. 3. Pre-push hook. This hook runs before a push is executed, enabling you to perform additional checks or validations before the changes are pushed to a remote repository. For instance, you can use a pre-push hook to run automated tests or perform security scans. 4. Post-commit hook. This hook runs after a commit is created, allowing you to perform tasks that are dependent on the commit, such as triggering a build or deployment process. 5. Post-checkout hook. This hook runs after a branch is checked out, which can be useful for tasks like setting up the development environment or updating configuration files. 6. Post-merge hook. This hook runs after a merge is completed, which can be helpful for tasks like updating project dependencies or generating release notes. By understanding the different types of Git hooks, you can choose the ones that best fit your development workflow and automate various tasks to improve efficiency and consistency. Git hooks can be configured in two ways, as local hooks or global hooks. Local hooks are stored in the .git/hooks directory within your Git repository. These hooks will only apply to the specific repository where they are located. Global hooks, on the other hand, are stored in the //git templates/hooks directory, or useprofilsent.git templates/hooks on Windows. These hooks will apply to all Git repositories on your system. To create a new hook, you can simply touch a file with the name of the hook you want to create, e.g. pre-commit, in the appropriate directory, and then make the file executable using the chmod +x command. Once you have created the hook file, you can add your custom script to it. This script will then run automatically when the corresponding Git event occurs, such as a commit, push, or checkout. By using both local and global hooks, you can tailor your Git workflow to your specific needs and ensure that your team follows consistent practices across all your projects. Let's look at an example of a pre-commit hook that can be used to enforce code quality and best practices in your Git workflow. This pre-commit hook performs the following tasks. 1. Checks for trailing whitespace. The hook uses the git diff check cached command to identify any trailing whitespace in the staged changes. This helps maintain a clean and consistent code base. 2. Runs linting checks. The hook executes the project's linting command, in this case, npm run lint, to ensure that the code adheres to the defined coding standards and style guidelines. 3. Runs unit tests. The hook runs the project's unit tests, in this case, npm test, to verify that the changes being committed do not break existing functionality. If any of these checks fail, the hook will exit with a non-zero status, which will prevent the commit from being created. This ensures that only high-quality code is committed to the repository, improving the overall code base and reducing technical debt. By implementing a pre-commit hook like this, you can automate the enforcement of code quality and best practices, making it easier for your team to maintain a healthy and well-structured codebase. Now, let's look at an example of a pre-push hook that can be used to ensure the quality and security of your codebase before it is pushed to a remote repository. This pre-push hook performs the following tasks. 1. Runs integration tests. The hook executes the project's integration tests, in this case, npm run test integration, to verify that the changes being pushed do not break the application's overall functionality. 2. Checks for vulnerable dependencies. The hook runs the npm audit command to check for any known vulnerabilities in the project's dependencies. This helps identify and address potential security issues before the code is pushed to a remote repository. If any of these checks fail, the hook will exit with a non-zero status, which will prevent the push from being executed. This ensures that only high-quality and secure code is pushed to the remote repository, reducing the risk of introducing bugs or security vulnerabilities. By implementing a pre-push hook like this, you can automate the process of running integration tests and checking for vulnerable dependencies, making it easier to maintain a secure and reliable codebase. Finally, let's look at an example of a post-merge hook that can be used to automate tasks after a merge is completed. This post-merge hook performs the following tasks. 1. Updates the project's dependencies. The hook runs the npm install command to update the project's dependencies based on the changes introduced by the merge. 2. Rebuilds the project. The hook runs the npm run build command to rebuild the project, ensuring that the merged changes are properly integrated and the application is up to date. 3. Sends a notification email to the team. The hook uses the git log command to retrieve the commit message for the merge, and then sends an email to the team, in this case, team@example.com, with the commit message as the subject. By implementing a post-merge hook like this, you can automate the process of updating dependencies, rebuilding the project, and notifying the team about the completed merge. This helps streamline the post-merge workflow and ensures that the project remains in a consistent and up-to-date state. The specific tasks performed in this hook can be customized based on your team's needs and the requirements of your project. In summary, Git hooks are a powerful feature that allow you to automate tasks and enforce best practices in your Git workflow. They are scripts that run automatically when specific Git events occur, such as a commit, push, or merge. Some of the common types of Git hooks include pre-commit, commit MSG, pre-push, post-commit, post-checkout, and post-merge. These hooks can be configured locally per repository or globally across all repositories to suit your team's needs. Git hooks can be used for a variety of purposes, such as enforcing code style and quality standards, triggering build and deployment processes, sending notifications or alerts, and performing security checks. By leveraging Git hooks, you can streamline your development workflow, improve code quality, and ensure that your team follows best practices. Throughout this presentation, we've explored several examples of how Git hooks can be used to automate tasks and enhance your Git workflow. By understanding the different types of Git hooks and how to set them up, you can start implementing them in your own projects and experience the benefits they can bring to your development process.